All right, so today we're looking at something that kind of feels like it's bending the laws of physics a little bit.
Just a little.
We've got the spec sheet here. It's for the NTI ST-C5USBV-R-1000S.
It's a bit of a mouthful. It's a VGA USB KVM splitter and extender.
Right. And that sounds pretty standard,
Yeah.
but the claim here is that it can send a high-res video signal and USB control up to 1,000 feet. I mean, that's just a massive distance. Usually with an analog signal like VGA, you go, what, 50 feet? And it's already a blurry, ghostly mess.
Oh, absolutely. It's basically unusable. We're talking about putting your keyboard and monitor 3 football fields away from the actual computer.
So the mission for this deep dive is, how on earth do they keep that signal clean over a standard copper cable?
Exactly.
So let's look at the basic setup first. It's not just a simple point A to point B kind of thing.
No, not at all. It's a splitter and an extender. So you have this local unit that plugs right into the host computer.
And that can be a PC, a Mac. I see it even says SUNN machine here.
Yeah, even some legacy stuff. And that one box connects out to as many as 8 of the remote units using, just standard CT5 cable.
Okay, so one brain, 8 different bodies, spread out all over a building, I guess. But that brings us right back to the physics of it all?
It does. And this is where the spec sheet is surprisingly honest about the trade-offs.
Oh, interesting.
So if you use the best possible cable, like a shielded CT6 at a shorter distance, say 200 feet, you get a massive 2048 by 1536 resolution.
That's super crisp.
Yeah. But we're here for the 1,000-foot claim.
That's the headline number.
Right. So at that full 1,000 feet, on just a regular CT5 wire, the resolution does drop, but only to 1920 by 1200.
Which is still better than 1080p. That's the amazing part.
Yeah.
But here's my big question. Whenever you run video that far over twisted pair, the color is separate. You get that weird, red and blue fringing on everything.
That's called video color skew. It's a classic problem. The different color signals are literally arriving at slightly different times because the wires are twisted differently.
So how do they fix it? Because sending a tech out to manually calibrate 8 different units sounds like a total nightmare.
It would be. No, they've automated it. The chipset inside has a video quality adjustment that it automatically compensates for that skew.
So it knows the cable length and just mathematically realigns the signals.
It basically retimes everything so the image looks perfect. It's very clever.
Wow.
And it pairs that with something called DDC emulation.
Okay, what's that in this context?
Display data channel. It's how your computer asks your monitor, hey, what resolutions can you handle?
And with 8 different monitors at 8 different distances, the computer would just get confused.
Exactly. So this unit pretends to be one perfect monitor. It keeps a list of safe resolutions and just feeds that single clean answer back to the PC.
So the computer is happy. It thinks it's talking to one ideal screen.
Mm-hmm.
Now, beyond the video, I'm looking at the other stuff it supports. And this brings up the question, why do this with hardware at all? Why not just use software like TeamViewer?
That's a great question. And the answer is security and specialized hardware.
Oh, okay.
Software adds a network layer. That can be a vulnerability. This is a direct physical connection. And more importantly, it supports CAT card readers.
Oh, wow. Okay, that's huge. We're talking about the Smart ID cards for government and military logins.
Correct. You can't just pass that through a normal remote desktop program easily. And this whole thing is TAA compliant, which is what you need for a U.S. government contract.
That completely changes the context. So this isn't for extending your home office. This is for putting a secure server in a vault and having a rugged terminal on, a factory floor.
Precisely. The remote unit is in a steel case. It's got surge protection. It's designed to survive where a normal PC wouldn't.
So what's the cost? I see a list price here of around $405.
Yeah, for the main unit. And that might sound steep, but when you think about the cost of not having to secure and cool 8 separate computers, the return on investment is probably pretty quick.
It is. It really redefines what a workstation even is. The computer isn't the box humming under your desk anymore.
No, the computer becomes infrastructure. It's just part of the building, like the wiring. You just plug your screen and keyboard into the wall.
Which leaves me with a final thought for you to chew on. If we can flawlessly extend a secure, high-res experience 1,000 feet over simple, cheap cable, why are our desks still so cluttered with hardware? Are we headed to a future where the PC is just a relic you only see in the server room?
It's certainly the way high security and industrial setups are moving.
A really fascinating piece of tech. Thanks for diving in with us.